So good evening everybody. It's from Jayshree at Department of Biomedical Engineering. I am going to take the ones complement and twos complement of the binary number, which is under the number system and logic gates. Okay. Let us see how we calculate the ones complement and twos complement of a single binary number. Let us see in detail in the upcoming slide. Okay. Ones complement of a number. So we have to calculate the ones complement of a given number. The ones complement of the given number is 0, 111. Okay. What is 0, 111? This is what the binary number. We have to convert this number into ones complement, right? So if you have to convert ones complement 0, 111, so we have to convert 1 by 0 and 0 by 1s. That is what the ones complement 1, 000. Okay. Here zeros are converted into ones and ones are converted into zeros. This is what the ones complement of the number. Next one, twos complement of a binary number. The twos complement representation of the binary number. Here the MSB represents the sign with the 0 as the plus sign and 1 represents the minus sign. The twos complement of 0, 111, that is the step 1. In the twos complement we need to take the answer, that is ones complement of the number plus 1. That is what the twos complement of the given number. Okay, so ones complement of the given number is what? 1, 000, and again it is converted into ones complement plus 1, right? So again this result will be added, that is 1000 will be added in the step 2. Okay, in the step 2, so 0, 1, 1, 0, ones complement of the number is 1, 0, 0, right? Plus 1 is added to the result of ones complement. So 1 is added at the last digit, that is 1000 plus 1, that is rightmost end. Okay, so we get the final answer as 1001, that is we need to tell us 1001. So initially this ones complement, that is twos. If you want to find out the twos complement of the given number, first we need to take the ones complement and then plus 1 is added to the ones complement of the given number. So finally we get the twos complement of the result. So 1000 plus 1 is what? 1000, that is 1001. So let us see what is the applications of the ones complement. So ones complement is simply a bitwise NOT gate, right? If you have the inverter, right? If you have the inverter at the home, right? If it is current is available, the UPS is getting battery charging, right? The current is not available, the UPS is sending the battery out, right? Similarly here, the ones complement is simply a bitwise NOT gate. The twos complement is the most commonly used to representation of signed numbers because it obeys the rules of addition and subtraction. If you add 1 to 111, you get as 000. This is what the applications of ones complement and twos complement. Okay, let us see another one more applications. Ones complement, that is twos complement of the number, is the most common method of representing the signed digits, right? Positive, negative and 0, and also the integers on computers, and more generally the fixed point binary values. This is what this applications of twos complement number. So first we need to calculate the positive, negative and 0 integers on computers, and more generally the fixed point binary values. The twos complement uses a binary digit with the greatest place value assigned to indicate whether the binary number is positive or negative. This is what this twos complement uses a binary digit with the greatest place value as the sign to indicate whether the binary number is positive or negative. We need to find out, right, whether the binary number is positive or negative. There are only two possible outcomes, right? So for this we need to identify if the MSB bit is 0, we need to identify this is as it is a positive number. If the MSB bit is 1, it is said to be the negative number. So this is what the applications of this 1's complement and 2's complement of the given binary number. So number 1, it is used as a bitwise NOT gate, and 2's complement is most commonly used to representation of signed integers because it obeys the rules of addition and subtraction. And 2's complement is the most common method of representing signed integers on the computers, and 2's complement use binary digits with the greatest value as a sign to indicate whether the binary number is positive or negative. Thank you.